How to determine if a function is one-to-one algebraically. Okay, so if you're asked to show that a function is one-to-one algebraically, the thing to keep in mind is that if f of x1 is equal to f of x2, then that should mean that x of 1 is equal to x2. So we're going to use this part of the definition of a one-to-one function to prove this. So let's start with just this assumption. If f of x1 is equal to f of x2, that means that 2x1 minus 3 should equal to 2x2 minus 3. So this is f of x1, and this second part is f of x2. And then I just solve. Divide both sides by 2. And we get what we expected. x1 must be equal to x2, and that proves that f of x is equal to 2x minus 3 is a one-to-one function. You could also look at the graph just to really verify this. And here's the graph of 2x minus 3. And we see that if you were to use something like the horizontal line test, you only pass through that curve at most at one point. Let's look at the next one. Again, we're going to use this definition of a one-to-one function on the side here, and we're going to assume that g of x1 is equal to g of x2, and then solve to verify that x1 is equal to x2, or in this case we're already told that it won't be, so let's see how that pans out. So x square root both sides, and I'm left with the square goes away. And so this is a little interesting. We have plus or minus x1 is equal to plus or minus x2. This actually divides into several different cases. We have to use all the combinations of the pluses or minuses. So for example, we could say that positive x1 is equal to positive x2, which is what we expect. We could also say that negative x1 is equal to negative x2, which is the same thing as x1 equaling x2. So both of these would be fine to meet the standard for a one-to-one function. But on the other hand, we also have to say that positive x1 is equal to negative x2. And we also have to say that negative x1 is equal to positive x2. And these are distinct points, which means that this is not a one-to-one function. We could verify that with the graph as well. And we see that if we do the horizontal line test on this graph, we're crossing the graph at more than one point, which verifies that this is not a one-to-one function. You can restrict the domain or restrict kind of the graph to make it one-to-one, right? You need to get rid of the second areas that this crosses the graph. So for example, I could just grab this second half here, get rid of it, and now it's only crossing at one point here and here. So if you were to restrict domain and say for all x's such that x is greater than or equal to 0, it is 1-to-1 on this restricted domain. And so sometimes you will restrict domains to make a function one-to-one.